All right, so the next part of Chapter 7, and the part that is going to take up the whole of Chapter 7 pretty much, in one form or another, one derivation of this or another, or one integration of this or another, rather, is this thing called the normal probability distribution or a normal curve, so also called a normal curve. And so the normal curve looks something like this. So we've got a flat line here. It's bell-shaped. It's symmetrical. These two halves should be identical. I am not the best artist, so bear with me. Pretend they are identical. So the curve is symmetrical. Which means these two halves are identical, right? We've got a couple of tails here. And the reason why this doesn't actually touch the axis is because theoretically this curve extends to negative infinity. And similarly over here it goes to positive infinity. And the nice thing about a normal curve is that in this symmetrical line right in the middle, we have our mean, which is equal to our median, which is equal to our mode. So our normal probability distribution, it's going to have this bell shape here with a single peak at the center. Its distribution is symmetric, meaning that this should look like this on the other side. It's asymptotic, meaning that this should never touch this one, and this should never touch this one. It's completely described by this mean, well, this mean. And then the other part that's describing it is the standard deviation. So let's write that down somewhere. That normal curves are completely described by their 1, mean, and 2, the standard deviation. So not all of the normal curves that we're going to be looking at are going to look like this, though. If we have ones that have less of a standard deviation, we are going to end up with things that are pointier. So if this green curve has a standard deviation of 1, then we could say that this orange curve has a standard deviation of 1/2. So it's a tighter cluster to it. And then if we wanted to have fatter tails, well, fatter tails would look something like this. So fatter tails would have a variance of somewhere like 3. Again, still symmetrical, still extending into infinity, still not touching the axis, right? I kind of drew these a little incorrectly because, as we can see here, they are touching the axis, so that's incorrect. Should be changed. We're not gonna. But all of these are normal curves, so it's easy for us to get comfortable with the very, the bell-shaped green one that I initially drew. But it's important for us to remember that as long as it's symmetrical and has this bell shape. It can be a really narrow bell, or it can be a really, really fat, wide bell and still be a normal distribution.